Use the binomial distribution. If n is equal to 6 and p is equal to 0.3, find the probability that x is equal to 3. There is a resource attached here. Let's take a look. This is the binomial probability distribution formula. So with the elements that were given in the problem, we should be able to carry out this calculation to get the answer. Notice that we have a simplified version of the formula down here because this first part of the formula is the combinations formula. So there's a number of different ways you can approach doing this problem. First of all, if we use the formula, we will do a calculation written out on paper. But you also have a formula in Excel that will do this for you. That's the binom.distribution formula. It asks for the number S, which means the number of successes, and that is X, which was given here as 3. Then it wants the number of trials, which is our N. Here that's 6. Then the probability of success, which is P, 0.3. And finally, we will choose false for cumulative because we want the probability of x being exactly equal to 3 and not 3 or fewer. So this is the answer. Now it is important to get to know the binomial distribution formula by hand. So I do recommend carrying out the probability distribution formula on paper so that you can verify that your answer is correct and so that you can get used to how that formula works. So here I have the formula. Notice that n is the number of trials, x is the number of successes, p is the probability of success in each trial, and q is equal to 1 minus p, which is the probability of failure in each trial. So writing out the formula here, the probability that x is equal to some specific x value is found by carrying out the combinations formula first, and then taking the probability of success to the power of the number of successes, and q, the probability of failure, to the power of the remaining trials that were not successes. So when we plug into this formula with the values we were given in this problem, and remember those values were n is 6, x is 3. Okay, so we're going to start with the combinations formula. So we have 6 factorial, then n minus x, so that would be 6 minus 3 factorial. Then x factorial, so again 3 factorial here. Then we will plug in the probability of success, which is 0.3 to the power of 3 successes. Then the probability of failure, which is 1 minus p, is 0.7, and there would be 3 trials out of the 6. If 3 trials were successes, then the other 3 would be failures. Okay, so this part of it is pretty simple and straightforward. This part, we just have a little simplifying to do if we're doing it by hand. So that's 6 times 5 times 4 times 3 factorial. And then I have 2 3 factorials down here. And notice that I stopped expanding here because I wanted to have this piece cancel out with this piece. So those cancel to 1. Now 3 factorial simplifies to 3 times 2 times 1, or 6, which will cancel off with this 6 here. So in the end, we end up with all the stuff in the bottom has canceled out, and we just have a 5 times 4 in the numerator, so that simplifies to 20. And then we'll multiply it times the rest of the pieces here, and we will get the same answer that we got by using the binomial probability distribution formula in Excel. Equals 20 times 3, or excuse me, that should be 0.3 to the power of 3, then times 0.7 to the power of 3 also. Okay, so there's my answer, 0.1522, which is the same answer I got up here by using the binomial dot distribution formula. Another thing to notice is that the 20 could have been found by using the combinations formula in Excel. So let's combine without the E, the number of trials, comma, how many we're choosing to be successes. So that would be 3 here. And you can see I get that 20 that way as well.